Alright, so we've done addition, we've done subtraction, we've done multiplication, we've done basically everything except division. So, enter quotient rule. If u and v are differentiable functions of x and v does not equal 0, then the derivative of x with respect to x of u divided by v is equal to v times the derivative of u with respect to x minus u times the derivative of v with respect to x all over v times v, otherwise known as v squared. It can also be written as this, which again is usually the one I prefer writing out, which is the derivative with respect to x of u divided by v is equal to v u primed minus u v primed all over v squared. So it looks great, doesn't it? Well, luckily for you, it's not as bad as it seems. So I end up saying like low d high and high d low and all of that kind of deal. So if we replace u with high and v with ho, then high is for high up there in the numerator and ho is for down low. I usually end up replacing ho with low because, let's be honest, it sounds bad. In the denominator, and let d stand for the derivative of. So low d high minus high d low all over low low. That's what I end up saying, again, just because this sounds bad in today's age. Alright, so now we can just kind of remember that, and like I said, it seems like a lot right now, but it's really not as bad as it seems. So the important pieces from this is I'm probably going to need the derivative of u and the derivative of v still. So in this case with division, my u is always going to be my numerator. So in this particular example, 14, my u is going to be x. And my v is always going to be my denominator, which is x squared plus 1. So then du, or u primed, is going to be equal to just 1. And v primed, or dv, should be equal just to 2x. Alright, so now I've got v times u primed minus u v primed all over v squared. Should be the derivative with respect to x. Okay, so v should be equal to x squared plus 1 times u prime should just be 1 minus u should just be x times v primed should be 2x all over low low, which is going to be v squared, which is just going to be x squared plus 1. Low d high minus high d low all over low low, which is why it gets that squared. From here, all we gotta do is simplify. We can do this. We can distribute out that 1. I just get x squared plus 1. And then I distribute x times 2x should just give me minus 2x squared all over x squared plus 1 quantity squared. So all in all, I get negative x squared plus 1 all over x squared plus 1 quantity squared. And unfortunately, in this case, those aren't going to cancel, so this is as simplified as I can get it. So let's move on to the next one. Alright, so I've got my high, which is u in this case, which is 5x squared. I've got v, which is x cubed plus 1, so u primed is equal to 10x. And then I've got v primed, which is equal to 3x squared, and that's it. So, d derivative with respect to x, again, your d's should be looking like that curvy thing that I keep making when you are taking the derivative. It is the proper notation. Alright, now that side note's over, I can actually take low, which is my derivative, which is low. So I should get just x cubed plus 1 d high, which should just be 10x minus high, which is just that 5x squared. D low should just be that 3x squared all over low low, which should just be x cubed plus 1 quantity squared. Distributing this out, I should get 10x to the 4th plus 10x minus 15x to the fourth all over x cubed plus 1 quantity squared. Combining my like terms, I should get negative 5x to the fourth plus 10x all over x cubed plus 1 quantity squared. And that's about as simplified as I can get it, so I am done. So, with that, I'm going to be done talking about all the special rules. Next, I'm going to be talking about higher order derivatives because we can take more than just the first derivative. Surprise, surprise, we can take the derivative until we run out of derivatives, basically. So as long as they exist, we can keep using this notation. So second derivative would be y double primed, third derivative would be y triple primed. Another notation would be just like f primed of x, or the second derivative of y with respect to x. It's just another way to keep rewriting this. They're basically showing you different ways to write the fourth and fifth and sixth derivative. Notice how after the third derivative, you no longer have to put those little apostrophes there. You just have to put to the fourth or to the nth in this case in both places. So no worries there. We'll get to that in the next video.